Good evening. Today we will be covering Chapter 6. The lessons we'll be discussing focus on equations, functions, and inequalities. So let's get started. An equation is a mathematical statement indicating that two expressions are identical, equivalent, or essentially the same. So some of the key ideas that this particular lesson covers: to solve an equation, isolate the variable by applying inverse operations to both sides of the equation. Then check your work by substituting your solution for the variable in the original equation and then simplifying. For example, 3 plus 5 equals 4 times 2. 3 plus 5 is 8. 4 times 2 is 8. 8 equals 8. So that's one example of an equation. In the second example, we see a mathematical statement equating 10 minus 1 to 3 squared. 10 minus 1 is 9. 3 squared is 9. So example number 2 is a true equation in the sense that it accurately reflects two equivalent statements, as 9 does indeed equal 9. In the third statement, we have a coefficient outside of the term in parentheses. So from our previous lesson, we know that we need to distribute the 5 across the parentheses. So 5 times 3 is 15. 5 times 4 is 20. 15 plus 20 is 35. And we know that 7 times 5 is 35. 35 equals 35, equation 3. An equation can contain one or more variables. Solving for or finding the solution to an equation simply means identifying a value for a variable such that when the value found is substituted into its corresponding variable in the original equation, the substituted value makes the equation true. So for example, 4 plus x equals 11. The objective is to solve for x. So we know by induction that x is 7, because 7 plus 4 is 11, or you can simply just move 4 over to the right-hand side of the equal sign. Anytime you move a number over the equal sign, it changes its sign. The number changes its sign. So 11 minus 4 is 7. Therefore, we know that x equals 7. For this equation, we will divide both sides of the equation by 3. So 3 into 3 on this side is 1. 3 into 24 is 8. We know, or we find, that x equals 8. This particular equation, we move -5 over the equal sign. So again, once we move a number over the equal sign, it changes its sign. So moving -5 over the equal sign, -5 becomes a +5. -2 plus 5 is 3, and that's our solution for our third example. The basic strategy in solving an equation is to isolate the variable on one side of the equation, and you can do this by performing inverse or opposite operations. However, you must always follow one basic rule. Whatever you do to one side of the equation, you must follow through and do the same thing to the other side of the equation. So in this example, we're told to solve x minus 23 equals 45. So on the left side of the equation, the number 23 is subtracted from x. The inverse of subtraction is addition. So add 23 to both sides of the equation, which you can see here is done in light blue. 45 plus 23 is 68. 23 and 23 cancel out on the left-hand side, and we're left with x. And so we have our solution. And you can simply check your work by replacing the variable with the solution that you found and then simplifying. So we'll go back to our original equation and we'll plug in 68. 68 minus 23 is indeed 45. 45 equals 45. So we know that our solution, x equals 68, is true for this particular equation. If you are unsure about a multiple choice algebra problem, substitute each of the answer choices for the variables in the equation. You may be able to do this quickly using your calculator. The following example uses inverse operations of multiplication and division. This particular example, variable x is being divided by 2, and since multiplication is the inverse of division, you simply multiply both sides of the equation by 2. So multiplying the left side first, 2 divided by 2 is 1, so that leaves us x on the left-hand side. And since we've multiplied 2, since we multiplied the left side of the equation rather by 2, we're going to multiply the right side of the equation by 2. 2 times 17 is 34. That means 34 is our solution, and we can check by simply plugging 34 into the original equation. 34 divided by 2 is 17. 17 equals 17, and so we know that when x equals 34, this particular equation is true. In example 3, we're being asked to solve 5x equals 75. Since the variable x is being multiplied by 5, we're going to divide both sides by 5. So 5 divided by 5 on the left-hand side leaves us with x. 75 divided by 5 is 15. And you can check your answer or your solution by plugging in 15 into the original equation. 5 times 15 is 75. 75 equals 75, so we know that 15 is indeed the true solution for this equation. Practice exercises starting on page 931 to 934. Make sure that you are at least attempting a few of these as often as you can, or as often as possible. Solving multiple step equations. Most equations require more than one operation in order to find a solution. You want to follow these basic steps. Start by simplifying the equation, and you do this by combining like terms, and then perform addition and subtraction steps. Then finally, perform multiplication and division steps. Example 1, we're asked to solve 6x plus 5 minus 2x equals 25. What you want to do is start by combining your like terms. So we can see from our original equation that we have 6x, and then we also have a negative 2x. So those are our like terms with a coefficient and a variable raised to the power of 1. Combining those together, 6x minus 2x is 4x. Then on the left-hand side, we are left with a single coefficient, or we have a single coefficient 5. So we can move 5 over to the right-hand side of the equation to isolate our 4x term. And as mentioned earlier, anytime you move a coefficient over the equal sign, that particular coefficient changes its sign. So a positive 5 moved over the equal sign now becomes a negative 5, or you can just simply think of it as subtracting 5 from both sides. And then we're left with 4x equals 20. 25 minus 5 is 20. Then you divide both sides by 4 to isolate x, right? So 4 divided by 4 is 1. 20 divided by 4 is 5. And so we have our solution, x equals 5. And you can check your answer by plugging in 5 into the original equation. 6 times 5 is 30, plus 5 is 35. 2 times 5 is 10. 35 minus 10 is 25. 25 equals 25. And so we know that 5 is indeed the true solution for this particular equation. In this example, distributive property is used to simplify an expression. Notice that not every step is written out. So as you gain experience or confidence working on these, you can perform an operation on both sides of an equation in your mind. Okay, so example 2 asks us to solve -4, open parentheses, x minus 6, close parentheses, equals 2x. And so you want to use the distributive property to remove the grouping symbols or to remove the parentheses. So -4 times x gives us a -4x. -4 times -6 gives us a positive 24. And we set that equal to 2x. And then I went in here and just wrote the next step in for you, which is to add 4 to both sides. excuse me, we're adding 4x to both sides. Or you can move negative 4x over, you can think of it as moving negative 4x over the equal sign, and it then becomes positive 4x once it lands on the right-hand side. 24 is now equal to 6x because we have 2x plus 4x in the preceding step. And so now we divide both sides of the equation by 6x. 6 divided by 6 is 1. That leaves us with x on the right-hand side. 24 divided by 6 is 4 left-hand side. And you can check your answer by plugging in 4 into the original equation. Negative 4 times 4 is negative 16. Negative 4 times negative 6 is negative 24. Negative 16 plus 24 is 8. Okay, or you can just work on the information in parentheses first. So 4 minus 6 is negative 2. Negative 4 times negative 2 is positive 8. 8 equals 8. And so we know that our solution, x equals 4, is true for this particular equation. Some of the time, you will be expected to write an equation from information given in the problem. The problem will describe two equations that are equal. Write each expression in symbols and connect the expressions with the equal sign. In many problems, the word is indicates the equal symbol or the equal sign, okay? In example 3, we're being told that the product of a number and 6 is 44 more than twice the number. What is the number? We're going to start by writing an equation that represents the information that we've been given. So the product of a number and 6, product implies multiplication. A number, we don't know what that number is, so we're going to represent that with x and 6. So immediately we know that we need to be multiplying 6 by whatever number this is. We're going to, like I said, we're going to call it x. So you write down 6x. We know that is representative of the equal sign, so you write down your equal sign. 44 more than twice the number. 44 more implies that 44 is increasing, so 44 plus twice the number. This phrase implies multiplication. We don't know what the number is, so we're going to write down 2x. And now you just simply proceed to solve your equation. You subtract 2x from both sides of your equation. So subtracting 2x from the right-hand side leaves us with 0x. Subtracting 2x from the left-hand side leaves us with 4x. And so we have 4x equals 44. I skipped a step here, but just know that, or mentally you should be aware that you will be left with 4x equals 44 once you've subtracted 2x from both sides of the equation. And then you simply want to divide both sides of the equation by 4. 4 divided by 4 will leave you with x. 44 divided by 4 will leave you with 11. And so we know that x equals 11. And you can simply check your solution by plugging 11 into the equation that you specified. So 6 times 11 is 66. 2 times 11 is 22. 44 plus 22 is 66. 66 equals 66. And we know that 11 is the true solution to our equation. More practice exercises starting on page 937 to 940. So lesson 2 continues with word problems. Algebra problems describe how several numbers are related, as we just saw in the previous example. One number is unknown, which you will represent with a variable. Using the relationships described in the problem, you can write an equation and solve for the variable. To solve a word problem, decide what quantity will be represented by x, then write expressions for the other quantities in terms of x. So essentially, you want to write and solve an equation and then answer the question being asked in the problem. In this example, we're told that there are twice as many women as men in a class on auto repair. If there are 24 students in the class, how many are women? Well, let's express the numbers in the problem in terms of the same variable. So we're going to let x represent the number of men. And since there are twice as many women, we'll let x represent 2x So our equation will look something like this. We have x representing the number of men plus 2x, which represents the number of women, equals 24, the total number of students in the class. And then you just simply solve your equation. X plus 2x is 3x. To isolate x, we're going to divide both sides of the equation by 3. 3 divided by 3 is 1. So that leaves us with x on the left-hand side. 24 divided by 3 is 8. And so we know that 8 is our solution. And to check your answer, you can plug in 8 into the equation that you specified. So 8 plus 2 times 8, 2 times 8 is 16, is 24. And so we know that there are 8 men in the class, but the question asks us specifically how many women are in the class, right? So based on the information we found, 2 times 8, which is our solution for x, is 16. So we know that there are 16 women in the class, and 16 should be the answer that you put down for this particular example, or this particular problem. On the GED, when you find x, you may not be finished solving the problem as we just saw. You always want to reread the question as shown in the examples that we just worked. And you may need to use the value of x to calculate the solution in a multi-step problem. On to the concept of consecutive numbers. Consecutive numbers are numbers that follow in counting order. So for example, 1, 2, and 3 are consecutive numbers. The numbers 2, 4, and 6 are consecutive even numbers. And the numbers 1, 3, and 5 are consecutive odd numbers. In this example, we're being told that the sum of 3 consecutive numbers is 105. What is the greatest of the 3 numbers? Well, from our definition, we know that consecutive numbers are 1, 2, 3, and I went through the trouble of highlighting the different statements in different colors so that you notice a difference, right? The first statement is just telling you is simply defining consecutive numbers, counting numbers that you count consecutively. So 1, 2, 3, 4, 5, right? Second statement focuses on consecutive even numbers, right? And then the third is expressing consecutive odd numbers. Well, in this particular problem, we're not told that the numbers are even or odd, so we automatically assume that they are consecutive counting numbers, right? And so we're going to let x represent the first number and x plus 1 our next number. So you can imagine when you're counting, if you can picture the number line, the midpoint of the number line starts at 0, and then you have 1, 2, 3, and so on, right? So we can imagine that x here is being added to 0, but we don't show that. So that's why the next consecutive number logically is 1. You just simply represent that with your equation. The first number is x plus 0, or you can simply represent it as x plus 1 is our next consecutive number, plus x plus 2 equals 105 is our negative of the equal sign, and then 105 being the right-hand side of our equation, or the value on the right-hand side of our equation, or the value that we should specify on the right-hand side of the equation. So then you just simply drop your parentheses to add your like terms. X plus x plus x is 3x, plus 2 is 3. And so we subtract 3 from both sides of the equation to isolate 3x. We're left with 3x equals 102. From subtracting 105 from 3, we have 102. Then you want to divide both sides of the equation by 3 to further isolate x and solve your equation. So 3 divided by 3 on the left-hand side is 1. 102 divided by 3 is 34. And so we have a partial solution for our equation. And I say partial, well, x is indeed the solution for our equation. I should say partial solution to our problem, right? Because the question is asking us, what is the greatest of these 3 numbers? Well, we don't, initially we didn't know what x was. So looking at our original equation, we know that whatever x is, this particular term or this third consecutive number will be the greatest because x is being added to 2. And 2 is greater than 1, 2 is greater than the imaginary 0 that we have here. So we know that whatever value x is, this consecutive number will be increasing by 1. This consecutive number will always be increasing by 2. So by logic, this particular consecutive number will be our greatest, whatever value x takes on. And we can check that. Since we found that x is 34, let's go back to our specified equation. X is simply going to be 34 here. Here, x is increasing by 1, so 34 plus 1 is 35. And here, x is increasing by 2, so 34 plus 2 is 36. So based on the information that we found by plugging in x, we know that 36 is the greatest number in our sequence, right? You might need to use the difference between numbers to write equations. So in this example, we're told that the ticket prices for a play are $12 for adults and $8 for children. One evening, the box office sold 200 tickets. If the total box office receipts are 2,240 or 2,240, how many adult tickets were sold? Well, first you want to start by just kind of keeping track of all the information that you've been given in the problem, and that makes it easier to specify your equation. So we're going to let the number of tickets represent 200. Why? Because it simply just tells us that the box office sold 200 tickets. So the number of tickets equals 200. Then we go back to our question again. The ticket prices for a play are 12 for adults. So we're going to let x represent the number of adults. Why? Because it doesn't tell us how many adults, right? It just tells us that we just know from the question that there are adults there are adults present, right? So since we don't know the number of adults, we're going to represent that unknown by x, right? So we're going to let x represent adults, and then we read further. $8 for children. The price of the ticket for children, the ticket price for children is $8. Well, since we know that there are x number of adults in this total number of 200, then by logic, however many adults are in this mix, once we subtract 200 from the number of adults, the remaining number will reflect the number of children, right, in the mix. So we can restate that as 200 minus x. Why? Because 200 is the total number of tickets that were sold. And if you subtract the total number of tickets from the number of adults who bought tickets, we'll know that the remaining number of tickets went to children. So it makes sense to specify or to let 200 minus x represent the number of children. And then from that, we can continue with our equation. So we know that the ticket price for adults is 12. So we're going to multiply 12 by x. We know that the ticket price for children is 8. We're going to multiply 8 by our representation of children in the equation here, which is 200 minus x. Let's say that you're in a group of 200 people, and there happens to be 2 adults. So we specified that by x here. Those 2 adults will have to pay $12 each for their tickets, right? So 12 times x, or 12 times 2, will represent the number or the price of tickets for the 2 adults, which would be $24. Then we also know that subtracting or removing 2 adults from the total number of tickets sold will be left with 198, right? And that 198 comes from subtracting 200 from x, the number of adults. So if we want to find out how much was spent buying tickets for the children in the mix, we would simply multiply the number of children, 198, by 8. So I presented that just to make this, or just to explain what's going on with this particular equation, right? So we have 12x to help us find the number of tickets sold to adults, plus 8 times 200 minus x, which helps us identify the kids' tickets. And we know that that total sum should equal $2,240, which is representative of the box office receipts for that evening. Okay, so then we just simply solve our equation, and we're going to distribute 8 across the parentheses. 8 times 200 is 1,600. Positive 8 times a negative x is, then we subtract or regroup our like terms. 12x minus 8x leaves us with 4x plus 1,600. We're going to move 1,600 over to the right-hand side of the equation. So we'll have 2,240 minus 1,600. Or you can simply think of it as subtracting 1,600 from both sides of the equation. That will leave us with 4x on the left-hand side and 640, which is the difference between 2,240 and 1,600. 640 on the right-hand side. Then to further isolate x, we simply just divide both sides of the equation by 4. 4 divided by 4 is 1. That leaves us with 1x on the left-hand side. 640 divided by 4 is 160. And so we have our solution for the number of tickets that were sold that evening based on the information that we were provided in the question. Practice exercises on word problems start on page 942 to 945. So finally, lesson 3 covers inequalities. Some key ideas to pay attention to. You want to use inequalities to show the relationship between two unequal expressions. So an arrow, a symbol that looks like the tip of an arrow pointing to the left indicates less than. A symbol that looks like the tip of an arrow pointing to the right-hand side, with the tip pointing to the right-hand side represents greater than. A symbol, tip of an arrow pointing to the left with a line underneath it represents less than or equal to. And then this particular symbol represents greater than or equal to. The symbol always points to the smaller expression. Use inverse operations to solve inequalities. Reverse the inequality sign if you multiply or divide by a negative number. An inequality is a mathematical statement that connects two unequal expressions. The inequality symbols and their meanings are as follows, and we just went over them. This symbol represents greater than. The symbol with the tip pointing to the left represents less than. The tip pointing to the right with a line underneath it represents greater than or equal to. And the tip pointing to the left with a line underneath it represents less than or equal to. So an inequality is solved much the same way as you would approach an equation. You want to use inverse operations to isolate the variable. So in this particular example, we're being told to solve for x in the inequality. 3x plus 2 is less than 8. So you simply just subtract 2 from both sides of your inequality. 2 minus 2 is 0. 8 minus 2 is 6. And then you divide both sides of the inequality by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So the solution to this inequality is x is less than 2. And that just simply means that any number that's less than 2 will make this particular inequality true. And you can check that by substituting a number less than 2 for x. So let's say x is 1. 3 times 1 is 3. 3 plus 2 is 5, and 5 is indeed less than 8. We can pick, again, any number less than 2, right? So you can substitute 1.5, for example. 3 times 1.5 is 4.5. 4.5 plus 2 is 6.5, which is indeed less than 8. Let's try another number that's less than x. Let's say x is -3, okay? -3 times 3 is -9. -9 plus 2 is -7, -7 is indeed less than 8. So essentially, as long as you select any number on the number line that's less than 2, this inequality will be true, or your solution to this inequality will be true. Okay. There is one important difference between solving equations and inequalities. Whenever you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. So here we're being told to solve for n, and the inequality -2n minus 5 is greater than or equal to 3. So you start by adding 5 to both sides of your equation to remove the negative sign, to remove the -5. So -5 plus 5 is 0 on the left-hand side, and 3 plus 5 is 8 on the right-hand side. Then you want to further isolate x by dividing both sides of the inequality by -2. So -2 divided by -2 leaves us with n on the left-hand side. 2 divided by 8 leaves us with -4 on the right-hand side. But notice what happens to the inequality symbol. It's reversed. Why? Because we divided by a negative number. Okay, so the solution to this inequality is any number n that's less than or equal to -4. Okay, and you can check your answer. Let's say that x is -5. Okay, -5 is less than -4. So we plug in -5 into our original inequality. -2 times a -5 is 10. 10 minus 5 is 5, and 5 is indeed greater than 3. Okay, we can try another number. Let's try -10. Okay, we know that -10 is less than -4. So -2 times -10 is 20. 20 minus 5 is 15, and 15 is indeed greater than 3. Avoid the most common mistakes with inequalities, which is reversing the symbol accidentally. Always check your work by substituting any number that fits the solution into the original inequality. When an inequality contains a variable, there are usually several numbers that make the inequality true. For that reason, we often graph the solution. In the examples below, a closed dot means that the number is included in the set, and an open dot means that the number is not included. So the set meaning the number of solutions that make the inequality true. So the first example with x less than 2, we go to our number line and identify 2 on the number line, and we're going to have an open dot because 2 is not included in that set. So this inequality is represented by any number beginning at 2 but not including 2, and then continuing down the negative side of our number line, all the way up to -infinity. X greater than -3, we identify -3 on our number line. Again, we're starting, -3 is our starting point, but it's not included in the set of solutions or the set of numbers that accurately represent this inequality. So essentially any number to the right of -3, but not including, is an accurate representation of this inequality, x greater than -3. For this example, x less than or equal to 1, we identify 1 on our number line. And this time around, we identify 1 with a closed circle. Why? Because 1 is included in our set of numbers represented by this inequality. So any number starting at and including 1, and then moving to the left-hand side of the number line into -infinity is represented by this inequality, x less than or equal to 1. For x greater than or equal to -2, we identify -2 on our number line, and we identify -2 using a closed circle because -2 will be included in the set. So any number starting at and including -2 and moving down the number line into infinity is represented by this inequality: x is greater than or equal to -2. A compound inequality combines two inequalities. To solve a compound inequality, you want to separate the inequalities and solve both, and then combine the solutions. So in this example, we're being told to solve 3x plus 4 less than 5x, which is also less than 16 plus x. So you want to start by writing two inequalities and solve each inequality separately. Write two inequalities to represent this entire inequality. So our first inequality is going to be 3x plus 4 is less than 5. And we already know previous steps that we from previous examples that we want to proceed by grouping like terms. So we're going to subtract 3x from the left-hand side and do the same thing on the right-hand side. So we'll be left with 4 less than 2x. And to isolate x, we simply divide both sides of the inequality by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So the solution for our first inequality is 2 is less than x. And on to our second inequality. Again, we proceed the same way, and you want to reflect the inequality sign in your separate inequalities the same way that it appears in your original problem. So 5x, the right-hand side of this entire inequality, we're being told that 5x is less than 16 plus x, which is what is reflected here. And again, we want to group our like terms. We're going to subtract x from both sides of the inequality. Negative x minus x is 0. 5 minus x is 4x. And then to isolate x, or to solve for our inequality, we're going to divide both sides of the inequality by 4. 4 divided by 4 is 1. So that leaves us with x on the left-hand side. 4 divided by 16 is 4. And that leaves us with 4 on the right-hand side. And notice the direction of the inequality sign isn't changing here because we're dividing by a positive number. The only time the direction of the inequality changes is when you divide by a negative number. So for this particular inequality, the two solutions that we have indicate that any quantity or any number that's greater than 2 and less than 4 will make this inequality true. Well, what number could that be? We could just, let's look at our number line. This is our representation for x less than 2, right? So we use an open circle to show that we're starting at 2, but not including 2 in our set of numbers representing that particular inequality x less than 2. And then this is our representation for the inequality x less than 4. Again, we're starting at 4, but not including 4, but we will be including every number to the left of 4 into infinity. So from our number line, we can identify where these two inequalities they find overlap, right? And that's right here with the number 3. And if we think back to our solution, 3 makes sense because 3 is greater than 2, but it's also less than 4. Okay. And another way to check your inequality is to simply plug A into your original inequality. So I've done that here for you on the bottom left-hand side. 3 times 3 is 9. 9 plus 3 is 13. Less than 5 times 3 is 15. Less than 16 plus 3 is 19. And that makes sense. 13 is indeed less than 15. And both 13 and 15 are less than 19. Okay. So there are two ways of approaching finding the solution for your inequality. You can think through it logically in terms of what you found given the two inequalities that you solved. So initially we concluded that the solution to both our inequalities essentially mean that x is greater than 2, but is also less than 4. So what number lies between 2 and 4? 3. And that makes sense for the solution because 3 is indeed greater than 2, and it's also less than 4. Or you can just represent both inequalities on the number line. Look for where they find overlap, because their point of overlap will be the set of your solution, or the set of your numbers, or the set of numbers that represent your solution, and then go from there. Okay. So more practice questions starting on page 949 to 951, and that's essentially it for today's lecture.